Hey guys, good evening and welcome back to my channel again. Yesterday I promised that I'm gonna do go over the linked list again, the last problem, but I was trying to go through it and I still don't completely get it. Although if I am to do it because I memorized the code, I can write it again, but I don't think I understand fully. And if I get the same question on an interview or a similar kind of question on an interview, I don't think I can come up with a solution on my own. So I think the best way is to just go over all the main data structures first, and then in the end, I'm gonna make sure I do this question and the same type of question. So yeah, that way, I wouldn't just store this in my short memory, the memorization of code, but I will have the full understanding. So yeah, I'll just move on to the next main data structure, which is stack. So I'm going to go on to stack and queue, but for today, we're just gonna discuss stack. I'm sure I'm gonna share my video. Mhm. Oh, come on, please don't say that. Oh, it shouldn't be lagging. Please, come on. Come on, please. Okay, guys, I hope this is continuing its recording. And if not, I'm just gonna briefly explain. I'm gonna do Q today, and yeah, that's about it. I'm just gonna dive in. I hate this laptop so much. I'm gonna buy a new one once I have the budget. Okay, hopefully now it works. Okay, so what is a stack? So basically, stack is a data structure where you use the LIFO algorithm, LIFO, so last in, first out. So what does that mean? Let me visualize it on a Paint app. All right, let's say that we have a beaker like this, and we have a list of strings. So A, B, C. We're gonna push it in. So this method, when we have a stack in Python, we usually initialize stack as a list. And how we do it is by appending, but in a more general term, we just push it. So first in, and then B, and then C. So as you can see, we put the C last, right? Now, when we want to pop this list from the back, what would happen? We're going to take, because we're not going to take A first, right? We're just going to take the C, which is on the outermost top. So because C came the last, it's going out the first. So last in, first out. That's LIFO principle, and that's what stack is all about. This method is used, as I read it, in various situations. One of the most common situation that it is used is in a string, and we're going to try to solve one question utilizing this stack structure. Let's see. So this is the question. Valid parentheses. So an input string is valid if open brackets must be closed by the same type of brackets must be closed in its correct order, corresponding open bracket of the same time. So as you can see from the example, because it started with this symbol and it ends with the same symbol, it is true. But here, this, because it starts with this symbol, the outer symbol also has to be this symbol. But as you can see, it's not. Oh no, it is because we're, oh wait. Oh, so it doesn't matter. Okay, so as long as it's closed, damn, I've been solving this, but yeah, it doesn't matter. So it just needs to be closed in the correct order, and it just has to be the same type of bracket, as you can see here. So how I approached this was by utilizing a stack and also by using hash map. So um, we make a dictionary in which we put the input bracket as a key, and then the matching outer bracket as a value. So that way we can see which one is matching and which one is not. So until that part, I'm going to code it. So it's, like I said, we initialize the stack data structure with empty list, and then we're just going to name it as matching. This is too many brackets, right? And then this be this and um, yes, we don't need this. This. We should need this. All right, so we have a hash map here. Nice. Okay, so now what do we so basically the logic behind this is that um given a string, so given an element in a string, so we start with um let's say that there's like this kind of a string. So we start from the first element of the string, which is just a normal bracket. And then let's say that there's a beaker. We put it in this and then this as an order, right? From the string here. Now, when we are checking this bracket with a value from the hash map, we're not gonna check from here, right? We're just gonna check from the last input, which was the square brackets. So this will check with the next element. No, not the next element, the matching element from the initialized hash map. And if it's matching like this, then it means it's gonna pop. So we're gonna state that condition. And then after that, we're gonna check again and then again. So that's how it works. It's pretty simple. I think stack is the simplest data structure. Well, I mean, from this exercise. I don't know how hard it's gonna get. But anyways, for element in S is a string. If element in matching then stack dot append element. If else, if it's not matching, if not in stack, we just return false, right? Or else, um, um, yeah, we're gonna define previous pop, and if the value of the matching, this previous opening is not equal to the element, then it's also false. So if there's no element, simply this opening then turn, we have to return, we have to oh, it's the opposite. Ah, wait, this has to be not, because it's the opposite. Yeah, so as you can see, it's correct. This was pretty simple. I think we can do some more challenging questions tomorrow, and then also see some more cases where the stack data structures can be used instead of strings. But anyways, thanks guys for listening. I hope to study again tomorrow with you guys, and hope it wasn't cut. Ugh.